Hi there, I'm Jackson Marusars, and I'm the Technical Product Manager for our CUDA developer tools here at NVIDIA. Today, I'm going to be giving the presentation, Demystify CUDA Debugging and Performance with Powerful Developer Tools. Quickly, I just want to go over an agenda so you know what to expect. At the very beginning, I'll give a high-level overview of the tools ecosystem we have so that you can understand the different tools we have available and the problems they're each designed to solve. And then that way also everyone's kind of on the same page with a basic level understanding. Then for each of our tools, I'm going to give a little bit more detail about how to use them, where you might find value, that sort of thing, and then spend most of the time talking about the new features we've been working on in the latest releases, as well as a couple that are coming down the line and the problems that those features are designed to help you solve. I've also got a couple slides at the end which are covering our current and future areas of focus. So you'll be able to see, not just from a feature standpoint, but from more of an umbrella big picture, where dev tools are going and some of the things we think are important. And at the very end, I'll share a few additional resources if you want to get more information. So this here is a high-level overview of our developer tools for CUDA, and it's broken down into 4 quadrants. We have our debuggers, which is CUDA GDB for the command line, and integrated debugging for Visual Studio and Visual Studio Code. We have performance analysis tools, Nsight Systems for a platform-wide performance analysis, and Nsight Compute for low-level detailed CUDA kernel analysis. CUPD is an API for adding annotations to your code, or API calls for creating your own tools or doing some very low-level tracing and performance collection. And NVTX is an annotation language so that you can mark up regions of interest to get some additional insights when you use profiling tools. Our correctness checker is Compute Sanitizer. This is a command line tool that basically allows you to set it and forget it. It will analyze your application as it's running. It will detect things like memory and threading issues and give you a detailed report afterwards. And then as far as development environments go, we do integrate into Visual Studio Code, Visual Studio proper, and Eclipse. To start, let's look at our compute debuggers and IDEs when you're just starting the development process of a CUDA application. CUDA GDB is our command line debugger that does both CPU and GPU debugging. So you can start a debug session walking through your host code and then jump into your device code, just like you would with a normal GDB session. All of the common flags and commands are supported. It supports things like stepping through code, setting breakpoints, inspecting inline functions and variables, all the things you would expect from a debugger. It's built on top of GDB. So if you're familiar with using GDB, you'll be very familiar with what's needed for CUDA GDB. And it has both local and remote connection support. Nsight Visual Studio Edition is basically debugging integrated into Visual Studio. And again, this one can do both CPU and GPU debugging. And what we're seeing is a lot more developers moving to Visual Studio Code. So we've put a lot of effort into making sure that's a supported environment as well. We have our IDE integration for Visual Studio Code for doing the same type of host and device debugging for CPU and GPU. And you can also remotely target Linux targets from both a Windows or a Linux machine. And finally, we do have Eclipse integration as well, although this one is not as popular as some of the others. But if you're working in the Eclipse environment, you can do CUDA debugging there. Compute Sanitizer I mentioned very briefly, but this is the automatic scanning tool to find bugs and memory issues. And it's actually built on 4 kind of smaller tools. We have a memcheck tool, which does memory access and leak detection. We have a racecheck tool, which does detection of data races and access hazards. Initcheck for uninitialized global memory accesses. If you're reading from a location that hasn't been written yet, you may have an uninitialized access issue. And synccheck to check for things like deadlocks and mismanaged thread synchronization. There's a link here where we have several samples if you want to check out some more details on how each of these tools can be run. Here's an example of a compute sanitizer report after it's run a memcheck test. So what you're seeing here is output in a shell where it's reported what address space was accessed. So in this case, it's a global write of 4 bytes. The access size is reported as well. You can see the access location. This is obviously really important for fixing the issue. As long as you have symbol information, you can find the actual line of source code where this issue occurred. You can find the memory address and the nearest allocation, and then also the call stack backtrace to see exactly how you landed at this memory error. It's not uncommon that you have protection in a lot of different call paths for memory or thread accesses, but there's a certain call path where you didn't add the protection or you didn't add the initialization, and Compute Sanitizer will automatically detect that specific call path. So now let's do a quick overview of the new features for our debuggers and our IDEs. For our IDEs, VS Code has added auto start tasks for remote debugging. These are basically quick scripts to do common tasks without needing to manually, input the same commands over and over. It's also added support recently for remote debugging for QNX or L4T targets. This is very important for Drive OS users, people in the auto space. QNX is a common operating system, so we've made sure to support those users as well, and support for Docker. We know that containers are becoming ever more popular. It's important to be able to debug and develop using containers, and VS Code has recently added support for Docker. On the Compute Sanitizer side, we recently added race checking support for device-launched graphs. If you're using CUDA graphs, you can launch them from the host, or there's a feature where they can be launched from the device. Now we have race checking support if you're launching them from the device. And memory checking support for both ATS and HMM. These are these new kind of memory management systems on the newer GPUs, and it's important to use those for performance, but it's also important to make sure that you're using those correctly. So Compute Sanitizer has support for memory checking there as well. A little bit of information about NVTX, which is our tool extension API. Here you can kind of just see really a high-level overview of what this feature is. It's a header library to decorate your application with annotations so that you can see more detailed information from the performance analysis tools. So you can do things like adding markers to your code at a particular region of interest, or ranges around something like a loop body or an arbitrary chunk of code that you want more info about. And then when you do an analysis, for example, with Nsight Systems, which is the screenshot shown here, you'll see your NVTX markers. When I talk about Nsight Systems, you'll see that there's a lot of information already provided automatically on the timeline. But if you want more, NVTX is one of the ways to do that. And the reference link is here at the bottom. NVTX is actually already included in many popular frameworks. So being NVIDIA and having so many different SDKs and software packages, we work closely to make sure that performance analysis of those packages is capable. And one way we do that is by adding NVTX into these frameworks. So if you're using DeepStream or Holoscan, these deep learning libraries or math libraries, NVTX is already in there. And when you do a performance analysis, you'll see those markers on the timeline. And if you are using a framework that doesn't seem to have NVTX, please reach out to us and let us know, because we're always prioritizing which ones to work on next. And the more we hear from users and developers, the better we can prioritize that backlog. Additionally, NVTX isn't just for C and C++ code. We have support for Python as well. So if you're running Python workloads and you want to see information on the timeline with markers from NVTX, we have those bindings. You can annotate your code with NVTX directly in Python. There's a pip package here, and it'll be profiled and visualized with Nsight Systems, just like it would if you were doing native C or C++ code. We know Python is ever growing, in the deep learning space and other spaces as well for HPC computing. So you'll see peppered throughout the talk several mentions of Python. Now let's look at our platform profiler, Nsight Systems. This one is designed to give you a holistic view of the entire platform and what was going on during your workload. We call it a system profiler because it does not just the workload or the CPU, but it does the CPU, the GPU, all the processes running on the platform, the memory, the transfers between over PCIe, and even some networking features for multi-node and cluster as well. It's designed to help you locate optimization opportunities, whether it's idle cycles when your CPU is working but your GPU isn't, or vice versa. And it does this by collecting and visualizing millions of events on an interactive timeline, but abstracting them away enough so that it's easy to understand. It helps you balance your workload across multiple CPUs and GPUs, making sure that you're getting use out of the resources that you're paying for. Sometimes adjusting the algorithms is what's needed. Sometimes adjusting the memory access patterns is what's needed. But whatever it is, you can visualize all those interactions on this timeline. Nsight Systems has a command line. It has a standalone GUI, and it also is integrated into the IDEs, so you can visualize the results in whatever way works best for you. It supports, Linux and Windows, and it has a Mac OS host, which means you can have the GUI running on a Mac. It doesn't support profiling Mac targets, but results collected anywhere can be brought back to your Mac laptop and opened up and visualized right there in a native GUI. It's for Pascal and newer GPUs, and there's just a link here for the documentation. So the things that you're going to see on an Nsight Systems timeline after you run a report are things like all of the processes and threads that were running on the CPU, the various states for those threads, whether they were queued up and ready to go, or running, or waiting for something. Here you're seeing a couple of examples of the frameworks we trace. So cuDNN, cuBLAS. We can see all the API calls from those underlying libraries. That's all happening kind of correlated on the timeline. And looking at the CUDA specifics, we can see the kernels as they're running. We can see the memory transfer activities, host to device, device to host. These are common bottlenecks in workloads. If you're not doing asynchronous memory copy, or you have some serialization around those transfers, you can really leave a lot of performance on the table. And it also supports multi-GPU. So if you have multiple devices, no problem, they can all show up on the timeline. And really the most powerful feature of Nsight Systems is this correlated timeline and its interactivity. So it has the ability, while it's collecting things at the sub-millisecond level, but also at the several seconds level, to zoom in, zoom out, filter on the regions of interest to see exactly what's going on at any given interesting period. So if you see, a gap, if you see a spike, you can zoom in, really detailed and see at the very fine granularity what's going on the timeline. Next, let's talk about some of the new features that have been added to Nsight Systems recently. So Grace host profiling using CPU metrics was just recently added. Obviously, the Grace Hopper platform and the Grace CPU is a powerful piece of the HPC and computing ecosystem. So we want to make sure that you're able to profile not just the GPU, but the CPU as well. So we have hardware counters on the Grace CPU that can be visualized in Nsight Systems. So these are going to be things like CPU core and uncore events sampled for each individual CPU. This allows you to visualize the parallelism effects. Do you have all your CPUs busy at the same time with cycles active and that sort of thing? And also the memory subsystem. Do you have a lot of cache hits, a lot of cache misses? How many instructions are you retiring? If you've done CPU performance tuning with metrics in the past, you'll be very familiar with what these things are kind of showing you. Also, the L3 coherency fabric and socket-to-socket traffic can be collected with these metrics. You can vary the sampling frequency. If you have very short runs, obviously you can bump it up. But if you want to run a little bit longer, it's going to collect more data. Sometimes lowering the sampling frequency can help there. And again, just like everything else that I mentioned, this is correlated on the timeline with your GPU and the CPU activity as well to see data movement, if that memory access pattern might be affecting your cache hits, and again, zooming and filtering fully supported. Let's just look at a quick example, not terribly interesting, but kind of the canonical example for performance is a matrix multiplication. It's running just on the host here. We're not talking about the GPU, but we have a single-threaded CPU matrix multiplication, and we can see here that the L1 data cache refill metric is very high, meaning that we're not hitting in our L1 cache very often, and we have to go beyond it. By investigating the code, we could tell that a access pattern, kind of a loop interchange was required to make sure that we're striding through the arrays in an efficient way. And just by changing that access pattern, we're able to see in the screenshot at the bottom that the cache refill rate has gone down significantly, meaning we're hitting in the L1 cache much more than we were before. So just something to be aware of, that CPU tuning is still important. And on Grace, we have CPU counters in Nsight systems. Jupyter Lab integration updates is another one that we've been spending time on. We want to meet developers where they are, and Jupyter Lab is a popular platform for doing software development. So what we've done is we've created an extension to Jupyter Lab that allows you to use Nsight systems to profile individual Jupyter cells. You can get the text-based results right there in the Jupyter notebook, or we also have a streaming GUI, so you can have the results pop up in the Nsight systems GUI after you've run the profile in your Jupyter notebook. There's a container that has all of the functionality necessary to stream the GUI. So without an X Windows server on the machine where the analysis is being done, you can have this container and stream the GUI out just by using the container. That's what's used in the Jupyter Lab, but it can also be used in other workflows as well. There is a lab that should be available on demand, linked here, where we actually use Jupyter Notebook for doing performance analysis with both Nsight systems and Nsight Compute, and you can see this integration in action. For Python profiling, Nsight systems has added several features. Python call stacks and included in the CUDA API backtrace are available. So now if you started from Python, you've gone and made some function calls, maybe they go into a C library, which eventually calls a CUDA kernel. That entire call stack can be visualized at the CUDA API when the kernel is called. We also have tracing of the global interpreter lock, the GIL in Python. This is a well-known performance limiter for Python applications, causing synchronization of the interpreter and seeing which thread is controlling that. How is that affecting the utilization of your workload is very important, and it's visualized on the Nsight systems timeline. And then also a lot of frameworks that are used by Python developers, whether they're actually implemented in Python, have Nsight systems annotated regions as well. So as I mentioned with NVTX, if you're using something like Rapids or Spark or CV CUDA, even from Python, you're going to see information on the timeline related to those frameworks. The cluster and recipe framework improvements that we've made recently are designed to help users that are running workloads across multiple nodes. If you're running on a big machine with multiple nodes, what you're going to be doing is running an Nsight systems profile on each one of those nodes and getting back a report. From there, if we didn't have this system, you'd have to open up each one individually and try and compare them to find something interesting. What this cluster and recipe framework does is it allows you to take all of those reports in a single directory, and using kind of some smart Python scripts that we've included and also is extensible so you can write your own recipes, it will do an analysis of all of those reports to try and find interesting performance information. So you can find things like multi-node heat maps that show InfiniBand congestion. You can see the throughputs of these networks for these large topologies. You can see GPU utilization heat maps across all of the GPUs on the entire cluster. That sort of thing is what the cluster and recipe framework is for. In addition to that recipe framework, we've added support for Kubernetes. So now we have the ability to use a sidecar injection into your Kubernetes workload to do an Nsight systems profile without needing to rebuild kind of your entire Kubernetes workflow or containers. You can use sidecar for that. We also have added NVIDIA switch per port support. So if you have one of the supported NVIDIA switches, you can see the traffic moving through those ports in your cluster. And this last bullet is related to what I mentioned on the Jupyter slide, where this ability to remotely stream the GUI from inside a container allows you to have the GUI, quote unquote, running on a cluster without a Windows server. This container will forward it to the machine where you're using it. One example of the recipe framework is here on the screen. So what we have here is we have a multi-process workload that was running using nickel, and it generated a bunch of reports on multiple GPUs, and we ran a recipe across all of those reports to generate these heat maps. And what we're seeing here is we're seeing the nickel utilization, we're seeing the compute utilization, we're seeing where they overlap, and we're seeing a aggregation in the top. So what you're doing here is you're trying to identify a workload balance, right? Do I expect phases of compute and then nickel and then compute and then nickel? Or would I like to see my nickel communication overlapped with compute? Depending on what you're expecting, these results may or may not be of interest, but you're getting an idea of a visualization that the recipe system solves. So the timeline down here is just a different visualization of these heat maps, and you can see pretty clearly that we've got phases here of compute, then nickel communication, then compute. But when you sum it all together, there's a pretty good utilization across the entire system. Now, let me talk about Nsight Compute. While Nsight Systems was our high-level platform profiler, Nsight Compute is going to be the tool that dives deep into these CUDA kernels, even at the source level, to find very specific performance issues as they're running on your GPU. We call this our kernel profiler, and it's a interactive CUDA API, quote unquote, debugger and kernel profiler. For debugging, what we really mean here is it has the ability to step through all of the CUDA APIs in an interactive profile, which allows you to find the exact kernel or the exact location you're interested in before running a profile. It has built-in rules expertise, so the metrics that are collected are automatically analyzed by Nsight Compute with this expert system, and specific results are presented to you, trying to identify the issue, what might be causing it, and some things you could do to fix it. It's fully customizable. Just like with Nsight Systems, you can change what data you want to collect and how you want the data to be displayed. Again, it has a command line, a standalone GUI, IDE integration, and support for remote targets, and runs on the same operating systems. Again, Mac just as a host. You can profile somewhere else and open it up in a native Mac GUI. This one's for Volta and newer GPUs, and there's a link here for the full documentation. The interface for Nsight Compute is broken down into sections after you run a result, and each section tries to cover kind of an area of the hardware or a descending abstraction, starting at the very top, which is the GPU speed of light, just giving you an idea of your compute and your memory subsystem and how utilized they are. Again, I mentioned you can customize what data is presented, and here you're seeing next to this yellow triangle a bottleneck that was detected. This is a rule that fired based on the metrics that were measured, and it's outputting what was detected and a human readable description. There's many of those, under the hood. Depending on what's collected, certain rules will fire if the threshold is outside what we've defined. There's a memory analysis chart. A lot of people find this useful to try and understand the GPU memory hierarchy, the various levels of the L1 caches, how it breaks down by global, local, shared, and your L2 cache and your system memory, as well as your device memory. You can see three throughputs or data rates to see what kind of bandwidth you're getting. And this can help you quickly identify whether there's a bottleneck in the memory subsystem. It's got metrics for peak performance and uses ratios to determine how close you're getting to those peak numbers. The other very powerful feature when it comes to actually fixing these performance issues is the source view in Nsight Compute. Provided that you've built your application with line info, most of these metrics can be correlated back to lines of source code. So you'll see for a lot of the metrics, the ability to zoom into the source level and see either at the source, the PTX, or even the SAS level where these metrics are occurring. You can also get the correlation between source and SAS. For example, here I've clicked on a line on the left side, and it's automatically highlighted the lines in SAS that the compiler generated from this source line. This can give you kind of some really good information if you want to get down into the details of GPU performance and coding, or you can not look at the SAS and turn it off if it's more than you ever wanted to see. Now I'm going to spend some time talking about the new features that we've recently added to Nsight Compute. The first feature I'll mention is called periodic metric sampling. Before we had this feature, almost all of the metrics in Nsight Compute were for an entire kernel. So you would get an aggregate number for the life of the kernel, how many cache misses, for example. But the limitation there is it doesn't expose any metrics that have changes over time within that kernel. What this periodic metric sampling does is it actually gives you a timeline for some of the metrics so that you can visualize whether this is a steady state metric or it's having a lot of changes within that single kernel. This is going to help you identify things like interkernel phases, where maybe you have access patterns that change throughout the life of the kernel, temporary anomalies, spikes, valleys in any of these metrics that you want to dig deeper into would be revealed by periodic metric sampling. Workload imbalance, this one's pretty common. You can see here, even in this screenshot, there's a bit of a tail effect where I have a lot of active warps for most of the kernel, and then towards the end, I have a tail where I just have a few. And whether it's some sort of a reduction or something like that, it's not uncommon that these workload imbalances reveal themselves with PM sampling. And at the bottom here, we actually have warp stall reasons as well. So one thing Nsight Compute provides is reasons that the GPU is stalled, and seeing those over time correlated with other phases of your application can help you understand what might be causing those stall reasons. Another recent feature, and this one was actually developed directly from feedback from our users, is a source code comparison. So now if you're doing performance analysis, making changes and doing another performance analysis, which is obviously a very common way to work, you don't lose the source code changes when you're looking at the new version. So you can automatically diff the two source files as long as you've imported them into your results to see the differences in the lines, what lines were changed, and obviously the metrics associated with those lines as well. So no need to open up multiple reports or anything like that. That diffing is done automatically. And that way you can also navigate to the changes quickly to see where your changes were made and how the performance was impacted. And we have heat maps in between the two source files. You might be a little bit difficult to see, but if you see kind of the orange and white and red ribbons in between the two source files, this is helping you quickly navigate to the areas where the most changes have occurred. So this one, as I mentioned, directly came from users. So if you have features that you want to talk about, get in touch with us. We're very responsive to user feedback. A new section was recently added to Nsight Compute called the workload distribution section. This one is going to help you understand the balance of work across the multiple SMs on your GPU. If you have a lot of SMs busy and not very many idle, or just a few busy and many of them are idle, we'll try to identify those load imbalances and give you information about what was detected. So in addition to firing the rules here at the bottom where you can see workload imbalance is detected, it also includes an estimated speed up. So we're trying to tell you here, if you were to more fairly balance this workload, you'd be able to get speed ups in this range. It's obviously an estimate. It's not perfect, but we're trying to help you detect the things that'll have the most impact and not go on a bunch of wild goose chases for performance issues that may not help you even if you fix them. So use this section to detect uneven workload distributions that could help you, that could keep you from achieving peak performance. A couple of features that are coming soon in Nsight Compute is a source page statistics window. This one is the ability to have the source page open and for any line get actual statistics, right? A source line may be executed multiple times, but getting the maximum values for metrics, the minimum values for metrics, the aggregate values for metrics of a source line, and then multi-select. In the past, obviously, you were just seeing the metrics for any line, but now you have the ability to select a few lines in the source file and get metrics related to that multi-select. We're also very soon going to be adding Python call stacks and syntax highlighting for Nsight Compute. Just as I mentioned before, Python is a place where people are working these days, and we want to make sure that it's supported. And for range replay, we have something coming down the pipeline called kernel timestamps. I didn't mention exactly how Insight Compute works. I didn't want to get into the weeds, but it has a very intelligent replay mechanism to replay kernels over and over and reset the memory state between each replay to collect this data. One way that you can do that replay, in addition to just replaying a kernel, is identifying an arbitrary range in your application and replay that range. If you do that, the kernels within that range get aggregated. But this new feature will allow you to see those kernels marked up on the timeline as they occurred within a range. A little bit of information about CUDA, which is our CUDA profiling tools interface. CUDA, which allows you to add these APIs to either build tools or do some quick profiling of your own code, has recently added new ones for instruction level SAS metrics. So if you want to get metrics at the SAS level, you can now do that with some of these CUDA APIs. Previously, this was only available through Insight Compute. CUDA has also added support for tracing device-launched graphs. I think I mentioned device-launched graphs earlier, but now if you want to trace those using CUDA APIs, you have that ability as well. Push buffer full events, the CUDA API queue, where you're in-queuing this work for your device, can fill up, and if it gets full, that's going to cause performance issues. There's now a push buffer full event that can be tracked with CUDA. The recent addition of lazy loading for CUDA modules and functions from the CUDA toolkit is a big performance benefit. If you haven't looked into that, check it out. But we do have some information in CUDA about the overhead that's being incurred if you're doing some of that. And then obviously performance improvements. I could have mentioned this for all of our profilers. We're always trying to be as low overhead as possible, or at least as accurate as possible, so we're not perturbing the run and reporting bad numbers. Same thing for CUDA. Trying to reduce the tracing overhead here is something that we've been focused on recently. So next, I'll just do a couple of reviews on the areas of focus we've been looking at, and we're going to continue to look at going forward. So one of those is obviously Python. Developer tools love Python. We know that developers love Python, and we want to be there with you. So we've added CPU call stacks, both for Insight Systems and coming soon in Insight Compute, GilTrace and Insight Systems, Jupyter Lab support, which is obviously really popular in the Python ecosystem, and working on increasing Python collateral samples, labs, anything we can in our tools. If you think there's a feature missing for the Python ecosystem, reach out to us and let us know. We want to hear about it. And I think I've linked to the same lab again here, where you can actually see a lot of these Python features in action. The second focus area I want to call out is cloud and cluster. As these machines get huge, being able to profile more than one node, being able to synthesize all of that data into something useful is important. So we've added features to try and help you do that, whether it's enhanced support for Kubernetes, this framework of recipes that are included in Insight Systems, as well as easily extensible. Just writing Python scripts, you can write your own recipes as well to see a lot of the performance issues on these multi-node systems where you're getting multiple reports generated. The ability to remotely stream a GUI from a large system that doesn't have a Windows server, Jupyter Lab integration for these multi-node recipes. And there's a link here to a presentation by one of my colleagues that shows a very detailed deep dive into these recipes and how Insight Systems is being improved for large workloads. Lastly, I just want to provide a couple of slides on additional resources. The first one here is a new developer tools video series. This was kind of a pet project, and we had a lot of people reaching out saying, people are learning through videos, people are not reading the documentation as much as they should be. Whatever the reason is, we wanted to make digestible overview videos for various features within the tools. So check out this playlist. We're going to be adding to it to add more details as well. They should be kind of easily consumable, self-contained videos about various features within our tools. And the last slide I have here is just talking about more places you can find developer tools across GTC, and all of these sessions should be available on demand, so you can find them in our on-demand library. We have tools about CUDA, we have sessions about CUDA where tools are included. We have sessions directly about tools as well. This lab should be available after GTC as well. and links down at the bottom for overview of our tools, as well as a page that has all of the different kind of tutorials and collateral aggregated in a single place. So with that, I will close. I will say thank you so much for attending. And for the last time, if you have any questions or feedback, please reach out to us either on our forums. We are always driving our roadmap based on developer requests, based on how our users want to use the tools. So don't hesitate to reach out, and we really appreciate the feedback. Thanks.